Alright, welcome back folks. In this video we're going to discuss another example of solving a system of linear equations using elimination. Elimination is a great method that we have of solving a system for a solution for that unique x and y value that satisfies both equations in the system. So the system we're going to work with right now is the following. 2x plus 3y is equal to 1 and 3x plus 5y is equal to 3. So we have two equations in this system. And the elimination method, remember, tells us to combine the equations together, right? Combine the like terms in the hopes that one of the variables will be eliminated, leaving us with just one that we can solve for a numerical value and then plug that back in and solve for the other. So let's try that here, right? So if we add these equations together in their current states, what do we have? 2x plus 3x makes 5x, 3y plus 5y makes 8y, and 1 plus 3 makes 4. Well, this is absolutely no good, right? Why is this no good? Well, nothing was eliminated. I just have another equation with two variables, but nothing went away. That's no good to us. So remember, one of the skills that we have is we're allowed to multiply the equations to change the way they look. In a previous video, we multiplied one of the equations and changed that around so that way it would eliminate one of the variables. Because remember, the goal is to get one variable that has opposite coefficients, right? Same value, just opposite signs. But here, if we take a close look at the equations, if I multiply just the second equation, is there any way I can, for example, turn a 3 into a negative 2 so it cancels out with the 2 in the first equation? No, I can't multiply a 3 by anything to make it a negative 2. Similarly, can I multiply a 5 by anything to make it a negative 3 so it cancels out with the positive 3 in the first equation? I can't do that either. So we are left with yet another option. We can multiply both equations. We can multiply both equations by different numbers, so that way we can make the cancellation happen. We can make it possible. So what are we going to multiply by? Well, let's pick a variable first. Let's say I want to make x disappear. That means I need to multiply 2 by something and 3 by something, so that way these two are the same number, just different signs. So what am I going to multiply by? Well, how about I multiply the first equation by 3. And I multiply the second equation by negative 2. So notice what I did here. I just multiplied the equations by the coefficient that I'm trying to change. So the first equation has a 2x. I'm going to multiply the second equation by negative 2. The first equation, I'm trying to change that into something with the second equation. The second equation has a 3, so I'm going to multiply the first equation by 3. So I multiply each equation by the opposite coefficient that I want. Now when I do that, look what happens. When I distribute the 3 to the first equation, what do I have? Well, 3 times 2x gives me 6x. 3 times 3y gives me positive 9y. 3 times 1 gives me 3. The second equation, negative 2 times positive 3x gives me negative 6x. There's that opposites that I want there, the opposite coefficients. And then negative 2 times 5y gives me negative 10y. And then negative 2 times 3 gives me a negative 6. Now I've got two new equations to work with, two shiny new equations that I can combine together, and let's see what happens. 6x and negative 6x, just like we planned, they eliminate. And I'm left with 9 minus 10, which is negative y, and that's equal to 3 minus 6, which is negative 3. So I have here negative y is equal to negative 3, which means y is equal to positive 3. So I have y is equal to 3. That's fantastic because now I can plug that into either equation and solve for x. So I have 2x plus 3y is equal to 1. Let's plug in 3 for that. And when we do so, we get 2x plus 3 times 3 is equal to 1. 2x plus 9 is equal to 1. So we subtract 9 from both sides. We get that 2x is equal to negative 8. Lastly, we divide both sides by 2. And we get that x is equal to negative 4. So I have x is equal to negative 4. y was equal to 3, so that means my solution is negative 4, 3. And we were able to do that using elimination. Now the trick for this one, remember, was we had to multiply both equations in order to make one of the coefficients cancel out. So this is how we can use elimination to change equations around and solve for that solution to our system. Check back in for more examples, guys. I'll see you next time.